Good morning, everybody, and welcome to our session today. This is the second of our monthly webinars, and we are excited to have Tim, a Genware Solutions Architect, present the spectrum of data science capabilities that are available within TIBCO Spotfire. Before I hand over to Tim, I would like to just make two announcements. This webinar will be recorded and be available for viewing later on. At the bottom of the screen, you will see a Q&A button. Please feel free to ask any questions during the webinar, and a Genware representative will answer it during the webinar. If we do not answer your question, one of our solutions architects will reach out to you directly. And with that, I would like to hand over to you, Tim.
Thank you, Jerry. Good morning, everybody. My name is Tim Crocker. I'm a solutions architect with Genware Computer Systems. What I'm going to do today is take you on a bit of a ride through all of the various statistical capabilities within the TIBCO Spotfire environment, including how it integrates into some of the more sophisticated statistical engines like R and the TIBCO's data science product Statistical. I've been working in business intelligence a very long time. My most recent stint in the industry with Genware over the last few years, but I spent 7 years at TIBCO working in the energy space with Spotfire. So I have a very good perspective on what Spotfire is able to do. So Genware is a global company. We like to think of ourselves as the smallest global company. We have offices around the world: Johannesburg, South Africa, Uruguay, and Montevideo, St. Augustine, Florida, and our head office in New Jersey, USA. We also have a presence over in Europe with a partner of ours, Data Shack, doing more data science and that kind of thing in the EMEA theater. So we see a lot of different technologies in the TIBCO space that help us bring analytics to our users. Today, we're going to focus on the data visualization and particularly the data science and side of it. So as we move forward, we look at kind of what we bring to the table. We're have a lot of skills in Spotfire, Streambase, the data virtualization product we've been using for many, many years prior to TIBCO actually acquiring it. So we have very, very deep knowledge in TIBCO data virtualization. But we're also active in the integration tools like Scribe and EBX as well. We have a presence on the web, and we're very, very closely tied to the TIBCO group. I work with TIBCO people daily, and as you can see on the slide, we've been awarded a Partner of the Year 2 of the last 3 years at TIBCO now. So a couple of slides. I'm not going to take too deep on the slides. I just want to introduce a couple of concepts along the way. One of the things we're going to talk about a little bit today will be TIBCO's Spotfire Statistics Services. Statistics Services is an engine that allows us to deploy statistical processes to our end users and have them interact with them dynamically, but be able to do so often without actually having to know much about data science at all. They understand the results of data science, but they see those things in charts and graphs or maps or whatever the case might be. One of the really key components of statistics services you see in the middle is the TIBCO Enterprise Runtime for R. R, if you're not aware, is an open source statistical programming language. It's pretty much the industry standard these days, with the exception maybe of Python, which is growing rapidly. But the TIBCO Enterprise Runtime for R is both embedded in the Spotfire Analyst desktop, but also a key component of the Spotfire Statistics Service server so that we can deploy those statistics out to our consumer environment. Just recently, the Statistics Services has been expanded to include 2 other products. The Python data function now, you can call directly from within the Spotfire Analyst, and you can make direct calls to Statistica workspaces also directly from the Spotfire environment. Similarly, we've always been able to make calls out to S+, open source R, SAS, and MATLAB using statistical services as well. We're not going to be touching those third-party tools today. We're going to be focusing on the TIBCO Enterprise Runtime for R and the Statistica data science components. So there's a lot of built-in capabilities in Spotfire we're going to look at today. The ability to do data science as that sort of citizen data scientist that we like to talk about. 1 click, 2 clicks, and be able to see a little bit deeper into our data than a simple chart or graph is going to let us do. So we have tools that will let us do data relationships, linear regressions, ANOVAs, that kind of things. We're able to do clustering across a couple of different techniques. Kmeans clustering we're going to take a close look at today, but there's also hierarchical clustering models as well. And then lastly, we can do some simple modeling, again with point and click exercise for both regressions to calculate values and classification modeling, which we're going to take, both of which we're going to take a nice close look at as we go through the demonstration here. The data relationships, as I mentioned, is something that we do see quite a bit, and there's a number of different options available depending on what type of variables you're trying to calculate. The numerical versus numerical, obviously, linear regression is something that we're all quite familiar with, but we can also do categorical versus categorical chi-square, or be able to calculate a categorical value from numerical ones using an ANOVA, for example. And we'll take a look at those as we go a little bit further in as well. Statistica is part of the TIBCO Data Science Suite. It is a powerful environment for the data scientist to develop and evaluate models and be able to then use that knowledge to enhance the visualizations on the Spotfire side by either pushing out data that we want to visualize, or, as we're going to see later today, actually interact with those workspaces dynamically, so that as we're interacting with our visualizations, we can have the statistical workspace on the back end dynamically calculating data for us. And we'll actually see how you hook that up when you enter into Spotfire. So with that, I'm going to switch over to demo and pull up Spotfire. And let me toggle over here. I have a number of different data files loaded into this analysis. As we go through, we're going to see everything from some energy data, well header information, and so we can take a look at some geospatial. We've also got some production data that's going to help us do some analysis as well. Other data that we've got, this is a manufacturing process. This happens to be an oil manufacturing process up in the Fort McMurray tar sands. So this is the data that they're using on a mechanical process to extract oil from sand. Here you can see we're using the top table that we're looking at here, in fact, is what we call the summary table. It's a standard visualization in Spotfire. It's one I actually don't see people use a lot, but it gives you a really, really quick look at your data the first time you load it so you can understand what it is you're working with. If you look down below here, you can see that there's a large number of descriptive statistics that are available in Spotfire. When I built this table, I chose the group on the side, but you can see that there's a very, very large number of them available. For those of you who have worked with Spotfire before, you'll know that adding a descriptive statistic or changing that is just as simple as choosing your selector here, and all the various types of statistics that you might want to apply to that series of data are available. And so here I've simply chosen max, as you can see, but this is a very simple way of aggregating and applying statistics to your data. Then we're going to step a little bit further here, and we see that we've got some lines. These are also can be driven by statistical processes. Here, with a single click, I'm able to add a standard deviation, a horizontal average, and the bottom standard deviation with a single click. Using Spotfire's tagging and trellising capability, I've actually split this time series into 2 phases so that I can see those control lines at their proper distance depending on where the data is. We don't want to use a control if we've made a substantial change to our process that was using the data from before. So we're the step up here, and we can establish a whole new set of lines. Looking at lines and curves, there's a number of different statistical lines and curves that Spotfire provides. Here's that same look that we saw on the prior page, a control chart with standard deviations. Here I've added all of the formulas and labels so we can see it a little more clearly what we're showing. But lines and curves is also enables us to do a forecast. Here I've taken a CPK value and I've projected what we're looking at over the next 30 days or so. Added in our confidence interval, and we can see, what our expected values would be. This is a really easy process to set up. In fact, if we look at that one, I'm going to go to the properties of this chart, lines and curves, and all I needed to do was set up our screen here. We can change our parameters, seasonal. Do we want it to reflect winter, spring, if there's a change in seasonal data and so forth, turn that on and off. And we can determine how many points and how broad we want our confidence level as well. All built in, all using the R engine under the covers. Here, we're looking at a histogram. I've used lines and curves once again to add, in this case, a Gaussian curve to help us better understand the distribution that we're seeing. And on the last chart, we're using a straight line fit. This is a linear regression. It allows us to see the relationship between two variables. And once again, I've added lines and curves to put the median and standard deviations on there to help us understand that. Now, the linear regression is quite interesting because the data relationships concept is a little bit more complex, perhaps, than just taking a look at two variables. So let's go to the next page here. This is the same chart that essentially the same chart we were looking at on the prior page. And I can look at the pristine phi-tane ratio variable here, but I could take a look at really any metric that I had available to me. Perhaps I want to see, this carbon isotope here, or perhaps the relationship to that one. I could go through each of my variables one by one and try to find out which of these variables had a high correlation to the pristine phi-tane value. But that would take me quite a while. So instead, I'm going to use one of the built-in tools. So I go to the Tools menu, and I have an option here called Data Relationships. Inside Data Relationships, I can choose the type of comparison I'm going to use. I'm going to use a simple linear regression. Here, because we've been working in Spotfire already this morning, we've selected the pristine phi-tane ratio that we see here. And we see a number of other variables that I've selected from my list that I think are the ones that I want to evaluate. I say OK. And with that, Spotfire is going to build a new page in my visualization, showing me the variable that I chose. Here are all the explanatory variables with the various statistics, including the R squared. So we can see, in fact, that the ratio between the carbon-19 and carbon-23 isotopes and this pristine phi-tane ratio is, in fact, the one with the highest level of correlation. But we can very easily now toggle through each of them and take a look at what their relationships are. And we have all of the information here to understand which of these are, in fact, more correlated to the pristine phi-tane. The next thing that we have available to us, also in data relationships, is the ANOVA. So here I'm using a very similar dialog. In fact, we can get in and take a look at that. I've chosen pristine phi-tane once again. We've chosen ANOVA as our type, and we've added in these categorical variables to see whether or not they have a correlation to pristine phi-tane. The result here, we can see the p-value. The lower the p-value we have, obviously, the better the correlation. And so the oil family, what type of oil it is the best indicator of this particular variable. This chart is a little bit interesting in that it includes what we call comparison circles. The center of each circle represents the mean of that particular group. And you can see as I highlight them, which of the particular groups they are, the centers of which we look at to understand where the means are. And the circles is really to sort of understand sort of where this particular box and whisker is going to be aligned with the others. So here we can see that particularly for these three oil types up top, that they are a very good indicator of a high level of the pristine phytane ratio. The next built-in tool that we have I want to take a look at is Kmeans Clustering. In the Kmeans Clustering module, which is also on the tools menu here, I'm going to come back to that. It requires a very special line chart, and that structure is what we see here. So what I've done is I've selected on my y-axis a number of columns. Normalized pristine phytanes and these other carbon values that we see here. They were selected from a list that we see over here. The normalization that you see in front was added by a transformation that we did when we loaded the data. We were able to point to a number of variables and say, please normalize these. In this case, I chose to scale them all between 0 and 1, as you can see on the y-axis in my plot. The scaling gives us a nice sort of general shape so that each well or sample that we see out here in the Gulf of Mexico is represented by one line. In fact, if we were to highlight a number of samples here, you can see, in fact, where they exist in that sample. So now what I want to do is I want to bring these together so that I can find like types of rock based on the chemical properties that they present. So I'm going to do that with clustering. So we go to the Tools menu, we say Kmeans Clustering, and when we do that, it finds charts that are valid. In this case, we want to choose from the page Kmeans Clustering, this chart that we're looking at here. Then we tell it what type of k-means we would like to do, similarity or distance. I'm going to be looking for similarity of shape. And then you can define how many clusters you want. I'm going to leave that as none. We say OK, and that clustering occurs in front of our eyes. For purposes of the demo now, what I'm going to do is add the k-means to my coloring so we can see it a little more clearly. And in fact, I could come over here now and add the k-means there as well. And this is even more telling because we can see that samples that were actually located geographically close to one another have in fact clustered quite similarly in terms of the rock properties. Now that is something that you would expect, but it's really nice to see that borne out by the algorithm. And now we can very easily go and we can take a look at each of our clusters and we can see, where they're located. And once again, that geospatial angle really comes out nicely in this particular example. Our next thing that we want to look at is classification model. So these are the same sets of data that we were just looking at when we did the clustering. And I've got two sets of data. One of them I've labeled my data for model training. This is data that I know. And so all of the spots that you see on the map here, the various colors, have been identified already in terms of what geological age, Jurassic Park and so forth, that we have here. The ones that are stars and black are in another data set, but they have not been identified. So what I want to do is use the knowledge in this data to develop a model that I can use to predict what the reservoir age is going to be in the data set below. So once again, we use the Tools menu. Tools, in this case, we're going to do classification model. I can name the model. Reservoir age. What type of model method? In this case, what I want to do is build a classification tree because what I want to do is predict reservoir age. So I have to choose the right data table. This is very important. Model for training is going to be the data that has the names in it. We want to predict, once again, reservoir age. And then, based on my knowledge of a little bit of geology, I know that some of the variables down in here are pretty good indicators of what the reservoir age is. So I'm going to go ahead and add those into my model. So here you can see those variables. So now we go ahead and say OK. And once again, Spotfire is going to build a page in the analysis for us. Here's the model summary. Here's the formula that we built. All of this text here in the middle is actually the logic that it went through when it created its tree and started to split based on values across all the various types of geological ages that we have. As we scroll a little bit further down, we see split errors and so forth, but most importantly, variable importance. Which variables and what value of importance that they have. So the order and then the order below. And then that's actually shown in this table down below. So in fact, if I was to use Spotfire's expand capability here, I can see that the model has determined that these three variables are the most important in terms of predicting the reservoir age. These two are in fact not as important. So if I wanted, and I will, I can go back into the definition now of the model, and I might decide that, you know what, I'm going to take these last three terms out of that model and rewrite it. And now we can see, again, the relative importance of those other variables. And then over here, each of these is basically a histogram like we see here of all the rows of data and the probability that that row was of this particular type, in this case, Cretaceous. If I was interested in, let's say, my lower Cretaceous, I can click on that link. It'll add that to the bottom here. I can expand and take a look at what this looks like. This is a really good example. These are all the samples that were predicted to have very low probability of being the lower Cretaceous. Here we have the samples that had a pretty high probability of having that particular value. So let's go back then and minimize. And up here on our model page, we have the ability to predict from our model. So let's click on that. And now I have a couple of different tables here. One of them is my training table. So my model training table is the model I just used to develop this code. What I want to do is use it against itself so that I can see how well we did. So I'm going to just choose then my model for training, say OK, and we'll let that prediction run. So let's go back to our classification modeling page here. What's happened now is that we've added a whole bunch of columns to our data that are showing for any given row what is its probability it's a particular type. And then at the very end, this is the prediction that it's actually made. So let's see how we did. I'm going to jump in here to my columns. Let's just quickly remove everything, put our ID back on. Let's look at the one that we had initially, and let's see what we predicted. So here you can see that we're not exactly completely bang on, but there's a lot of tie in terms of what it was and what we predicted it would be. And there's some that are not. So if we need to do some analysis now, we could perhaps go back and add in the percentage columns and understand that, you know, it was Jurassic, it chose Miocene, maybe Miocene was only 40 or 50%, Jurassic was 20 or 30%, so it chose Miocene, but we would understand that. But now we have a model, and we're relatively comfortable with how it's able to predict. So let's use it then to predict the data that we don't know yet. So we'll go back to our model page, reservoir age, and we will once again predict from model. This time, I'm going to use the for prediction table, which is the table that did not have the reservoir ages. So now once again, I say okay. And now we can go back to our classification modeling page here. And if I was to go, instead of by reservoir age now, we use the new class prediction, you can see that all the stars that were formerly black now have color. And in fact, I can go and isolate those, and we can see that all of the values that were formerly black that had no value, we've predicted using the model that we just developed inside of Spotfire. The next thing I would like to show you, and this is where we're going to sort of move from built into Spotfire to being able to interact with statistical engines outside of Spotfire. Here's the same data that we were looking at. We have the pristine biotane ratio shown by color on all the samples. And I can kind of understand, where they are based on color. But if I was able to use a geospatial regression, I would much better understand where the concentrations of this particular chemical were. So to do that, I need an R or TERR data function. So I go to my data menu in this case. I go to data function properties, and I need to register a new function. Here, I can go to the library if I happen to have some functions out there. In this case, I'm going to import one from my disk, and I've got one here called the TERR contour lines. And I say open. When that happens, you can see that somebody has written an R script interacting with the CRAN libraries and so forth to develop this. They've also nicely documented what the inputs and outputs were. And if you worked with Spotfire data functions before, they have defined what the inputs and the outputs for this particular data function are. That is really important because that is how we're going to wire this function into Spotfire. To do that, we simply say run. So now all of those variables that you saw on the prior screen are now presented to me with a dialog that'll let me tie it to my data inside of Spotfire. So how do we do that? Here, let's expand my description. You can see it's doing looking for an X variable that's going to be X coordinates or longitudes. So it's asking for a column, so I'm going to use the column input handler. And here you can see we're using the geochemical analysis for model training data, so I'm going to use the same one here. And I want to point to the longitude. If I so chose, I could filter the data. I'm not going to, based on marking. And then I go to my Y variable. It's also looking for a column, in this case, the latitude column. Then the Z or Z column, as we would say in Canada, is the variable that we actually want to do the regression on. So I'm going to point to the column here, and I'm going to point to that same variable that we're looking in our colors up on our map. Lastly, we have a smoothness scale. I could attach this to a document property, attach it to a slider, and that would allow me to dynamically change the resolution. For my purposes today, I'm just going to say that we have a value of 0.2. I want this function to refresh automatically. And then lastly, what's my output? It tells me it's going to be a data table, so I point to that output handler. I look at the dialog. It says it's going to create a new table for me called contour lines. I'm happy with that. So with that, I'm going to say, okay, and close this dialog. If you observed, you saw there was something running in the background. That function is now executed. If I use my data canvas to look at my available data tables, I see that I now have a data table called contour lines. I'm able to grab the geometry that was created by that data function and now add that as a feature layer to my map. And there we see the contour plot. I'm going to use my layer settings to make my contour lines now the active line, the active layer. I'm going to go back to my data panel. I'm going to take my level value, and I'm going to drop that on the color by icon. So now I can come over here. Let's take the ones that are maxed. Let's make those red and make the ones that are not so much the light blue. But let's even make that look better. I can right click, go to the layer settings for the contour lines. On the appearance tab, I can bump up my line weight a little bit. Make them a little easier to see. I can go to my color palette, add a data point. Perhaps we'll use the median value and let's make that white. And while we're at it, let's make the ones that are low really dark blue. And now you can see that we've got a layer. This all was dynamically generated by the statistical function on the fly. We can set it up so that it'll respond to marking, filtering, and every time we do those things, that data function would re-execute dynamically. We're going to see a couple of examples of dynamic functions here in a moment. Similar to R and TERR, we can call a Statistical data function and return the data back from that data science tool to Spotfire. In this particular case, I have a map and I've used the old-fashioned marking. So these two dark blue wells that are highlighted are the ones that we see on the map here right now. And when I'm looking at a well's production, if I'm an engineer, often what they want to know is what's the average. In fact, the average becomes the basis for a production decline curve. But the average, as you can see, if you use lines and curves in Spotfire, comes in as a straight line. It's just what was the average across all of time. And that's not what they want to know. They want to know is what's the average in any given month. So to do that, I'm going to use the Statistical data function. The Statistical data functions have been added to the Tools menu. You will now see a statistic option here. And when I click on that, we see a dialog. And the first thing I need to do is add a new workspace. So I go ahead, click on it, and I have one that's been developed for me. That's called the Final Normalized Data A Statistical Data Model. So I open that. This will take a second, and as that occurs, there's a runtime for Statistical now executing that has evaluated this model. So I can go inside it and understand what it's looking for in terms of inputs and outputs. Now this one's a little different than we saw when we did TERR. This one's just looking for a table. So in this case, I go to the columns and I then need to pass in monthly production data and I have to tell it what columns do I want to send in. Well, I'm going to give it the entity ID so I know which well it is that we're looking at. I'm going to pass in the oil and I'm going to pass in the normalized production period. Say OK. From an output standpoint, it's producing a number of different data tables for me. So for each one, I need to use the output handler and nominate that those things are going to be brought into a table. And now we'll just keep the name that they're brought in with. Once again, I'm going to click refresh function automatically. So if I've done everything correctly, as we run, that data function should be executing in the background. We can see, in fact, that there's a wheel turning, so there's a task executing, and that's now completed. So I go back to my data area. You can see that we now have a number of new data tables, finalized, normalized data, so forth have been added. So with that, I'm going to go to my chart, right-click, Properties, Lines and Curves once again. This time we're going to add a curve from column values. I pick the table that I want to use. This is going to be my final normalized data table. My X values are going to be the normalized production period. Now, I happen to know I'm going to have a little error here. I don't see my production period here. And the reason being is that when you do a line from column values, this has to be a continuous variable. So I'm going to close for half a second here. go back to my data canvas, take a look at my normalized final data, and I see that the normalized production period, if I look at its settings, has in fact come in as a string. So I'll use the wrangling capability right here in the data panel to change that value to an integer. So I've now changed its data type. With that, then, I'm able to come back to my visualization, go to lines and curves. Here I'm able to add a line from column values, choose final normalized data. Now you can see my X values come in with that correct period. Good. The liquid means is in fact the averages that I want. So now I can go ahead and say okay. And for our purposes, let's go and make that a dotted line, and let's make it really green. And we're going to update that automatically all the time. So we'll just let that happen. So now we'll close. Now I look at that and I go, wow, that line is not correct. It's certainly not the average of the two lines that we see above. So I probably made a mistake in configuring my data function. So I go back to my tools menu. I go back to Statistica, take a look at my settings, and I look and I'm looking at my columns. You scroll down a little. Ah, look at this. I have to tell it that I only want to pass in the marked rows. So now I say okay and close, and you can see that function is now re-executing, and in fact that line has now repositioned itself as the average of those two. We could verify that very easily by clicking on only a single well, let that average function run, and in fact the lines overlap one another. So here what we're seeing is an end user interacting with a visualization and having the result of a Statistica data function return the result in a visualization. For myself as an end user, as I'm interacting with it, I don't have to know that there's data science on the back. Now, I've shown you a couple of techniques. What I'm going to do is pop over and show you one more analysis here that's kind of taking this whole concept to a much deeper level. Here, we're looking at also production data. However, if we were to reset our marking and filtering here, you can see that this particular data set has literally 40,000 wells in the Eagleford Shale south of San Antonio where I live. Over here, we have all the various operators who are drilling. I might be curious how one of those, and I apologize, might be doing. So let's go ahead and pick Devon here, for example. So I click on Devon, the map immediately filters down to a set of wells. So I'm trying to understand how these wells are not only performing from a production standpoint, but I want to be able to calculate how much oil do I actually think will be produced from these wells. So I'm going to go and say, this particular cluster here is interesting to me. So I'm going to highlight those. And when I do so, that data is now dynamically going through the data model. You can see that this is the wheel turning in the background here. So we'll let that complete for a second. But I'm going to go to the next tab. And now what we see is in gray are the actual daily or monthly production of the wells that we selected. The green is the average of those wells calculated. And then the orange is the best fit forecast. So this is actually an ARPS decline that has been used to then project the data out past the end of production many months into the future so that we can understand, what the ultimate recovery out of that well might be. Here we're using the Spotfire capabilities to plot the curve, but then also to calculate the cum up to 100% so that we can understand, where's the best lifetime in this particular well. These are what we call type curves in the energy space. They use them to be able to establish performance of new wells. They'll take a look at wells in a particular area, develop a type curve, which is what we see here, and then they'll want to compare that particular well's performance against that curve over time. We've taken this particular analysis a step further in that what we've done is allowed the engineer to actually play with the parameters. So in this case, if I don't want to go out 200 days into the future, maybe I only want to look 150 days into the future, or months I should say, I can interact with that, have that type curve calculated on the fly. So in the energy space, this is a very useful tool to help organizations evaluate properties, but the moral that I really want to discuss, and as we come back to the end of our presentation today, is that there's a very wide range of statistical capabilities inside the Spotfire platform. We have everything from simple descriptive statistics, the ability to predict and optimize, and as you move into the TIBCO suite and we get into the real-time world of stream-based, being able to use those statistics and so forth out in that whole space. So with that, Jerry, I'd like to turn it back to you, and if there's any housekeeping here at the end. If you have any questions, I'm not sure if we have any in the panel. Happy to answer those right now, but that's the end of my presentation for today.
Perfect, Tim. This is Sherlock speaking. Thank you very much for a great presentation. We don't have any questions over here. Believe everybody's got access to us. You've got Tim's email over there. Reach out to Tim, Jerry, or anybody at Genware. We'd be happy to address any further questions that may pop up, or certainly walk you through anything that has been shown today specific to some of the things that you're busy doing at your site. So with that, Jerry, if you'd like to shut things down, thank you very much.
Thank you, everybody.
Thank you, Sherlock. Thank you, Tim. Thank you for that informative demonstration, Tim. I really appreciate it. We will send out an email to you with the link of the recording once it is uploaded. We will also announce the next webinar in that email. Thank you everyone for attending today's webinar. I hope you have a great day. Bye-bye.